So in this video we are going to solve the next episode of the jump game problems. The difference is that if you have seen the jump game 1 and 2, we always start from the index 0. But in this problem you have been given one array and also you will be given one the starting index. So in this case this is the index, so this is actually the index. So you have to start from the index 5. So if you see in this case we have the 2, 3, 4, 5, 6. So you have to start from the index 5th and you can jump as you used to do in the previous jump game. 1 point means either you can come here or here. This is 1 point, right? So you can come on the index 4 or you can come on the index 6, right? So you mean to say, if suppose this index denoted by I, so you can move I minus, and if suppose this array name is the nums, so you can move nums I plus minus. So in this case I is equal to 5 and num I, this is the 5 and num I is equal to this 1, right? So you can move either 6th position or the 4th position, right? So we can come in the 4 and the 5. So just you have to say that with this jump, could you able to reach the element or index where the value is 0? Let us see. So suppose now we reach here, and from here if you see again, this is the 3 and 4. So from here where I can go? If you see 4 plus minus 3, right? So we can go the 1 or index 7. And your index 7 is not there, so we can come on the index 1, right? And from here where you can go? So again this is value 1 and this value is 2 plus minus 2. So we can go either minus 1 or 3. Minus 1 is not there, so we can go the 3. So what is the 3 index? 3 index 0, and we can reach it, right? So what is the path here? If you see, whatever the path, from 5 we came here 4, from 4 we came here index 1, and from 1 we came here index 3. But the possibilities, there are many possibilities. This is not only one way. If you see here, from 5 also you can reach the 6. From 6 plus minus 2, so 4 and the 8. So we can come to the 4 also. And once come to the 4, then again from 4 we can go to the 1 index, because this is the already check 1 index, and from here we can come here, right? So 5, 6, 4, 1, 3. Another possibilities are there. So we have to return the true, because from the given starting point we could able to reach the 0 index. Okay, just check this one, how it is possible for this example or not. So if you see again I is equal to 2, and if you see the index 0, 1, 2, 3, 4, right? So where we are, index 2, we are here. So from here 2 plus minus 2, either we can go the 0 or we can come to the 4. So we can come the 0 and we can come the 4, right? Check from 0 it is possible or not, right? So again from here 0 plus minus 3, so minus 3 and 3, that is not possible. 3, so we can come here, right? And from here if you see 3 plus minus 1, either 2 or 4, so we can come to the 4 or we can come to the 2 index. Again where we start. So if you see all the permutation combinations, we cannot reach the index 0 if we start from the 2, so we can return the false. So this is the use case, this is the statement, and let us see how we can solve that. So before that, again if you convert, or you can think such a way that you can feel this is a the graph problems. How you can see, this is a binary tree problem. How you can see? So we have to start from the index 5, right? This is starting point. So if you see, this is the index 5 and 5 value is the 1, right? So or you can see here, right? plus minus 1, right? So either you can reach the 4 value, right? So we can reach the 4 or we can reach the 6 index. If you see the 4 we have the 3 value, so plus minus 3, and the 6 we have the 2 value, right? This is the 5, this is the 6, so 2 value. Again, if you see here, we can come to the index minus 4, 3, 1, and you can go the 7. And your 7 index is not there. If you see from 6, we can come to the 4 and we can come to the 8. 8 index is not there. What is the value of index 1? Plus minus 2. And what is the index value of 4? 3. So plus minus 3. Again, if you see here, this will become the 1 minus 2 minus 1. That is not there. And 1 plus 2. This is the 3 index. 3 index value is 0. And you can see that we have already reached our target, right? So again, if you want, you can continue. So this is and if you want to continue, let us see that again, just for namesake. 4 minus 3 is equal to 1 index. 1 index is equal to 2. And this is the 7 index that is not there, right? So if you see that, what we have to do to find out the solution, whatever the operation we are doing the one node, we are doing the same operation for the each node, right? Same operation what we have done here, we are doing the same operation we are doing here. We are doing the same operation here, right? Each node we are doing the same operation, right? So it's very easy to solve through the recursion. If you do the recursion technique, we can easily find out. So what you have to do, just you have to start from the 1 point and then again you make the 2 point and return back to the same method. That I will show to you, right? So what we can do that. So only thing is that there are the 3 conditions that you have to take care. So we have to not visit any traverse, any index that value is less than 0. So any time, if suppose your index is equal to I, so I always should your greater than 0, right? You have to not visit from here, right? This is the 0 index. And also this side. And this is your, how do you get the 6? Nums. If you do the nums length minus 1, you will get the 6, right? Or you can see always I should always less than the nums dot length. 2 conditions. Third condition, when you already visited one element, you should not supposed to visit again. So don't not visit if already visited. This is the third condition. 1, 2, 3, and fourth, during your traversal, if you encounter your nums I is equal to 0, that time you have to return the true. Otherwise, if all the traversal, if you do not get any this condition, then you have to return the false, that is out from the method. Let us do the diagram, how it works. So okay, so how the code would be there. Suppose method name is the can reach, and we get this array nums, and you will have the starting point. So what you have to check here? So first you have to check all this condition that you have to check it, right? First condition, start means starting your index of easy thing you can make as a I, what we discussed that. So okay, just make it easy, we can take the I. It is your starting point. So I always greater than equal 0, one condition. I should always less than the num length. Okay, and it should not visited. So what happen? We have to mark when you visit. So what I will do, once we visited, I will make this number into the negative number, just for the marking purpose. You can keep anything. For visited you can make the x, y, anything, but for the easy purpose we make the negative. If suppose if I visited here, I will make this 3 to the minus 3, that I will show you. So I should not visit the visited element. So for that you have to take the condition that nums I should equal greater than 0, means not visited. This means not visited. Visited value always the negative value. We start from here, and then if that element value, if nums dot I is equal to 0, that we discuss the third condition, then and there itself we will return the true, that we have already reached that. Till here it is okay. Then what you have to do, if it is not the case, then we mark this element visited, because we have already visited this element. So nums I is equal to, make the multiply by the negative, it will make the negative, right? So due to this your condition may be true and false due to this one, right? So what I did here, we came here and checked the element. It is that index should not less than 0, should is smaller than the length, should is smaller than 6, and this should not be visited. If this condition is okay, then I will check if this is the 0. If it is not 0, we make mark as a visited with the negative, and again I will call the same method. So what I will do, return, call the same method, can reach, pass the same array, but this time you know what I have to do, I plus minus nums I, right? Means I, this I 4 and this 3 value, this 3 is called the num and this 4 is called the I, right? So I plus nums I, you have to pass this one. Also whether this condition is true, also for the negative part, right? Nums I minus here, here is the plus, here is the minus I value. That's it. So if you start from here, this is here, it will go iterative recursion method. If you visited all the element and could not find out the condition, then if you return the false. This is the one way to solve that. Another way is the BFS, wait first search, that I will show in the second video, but let me just show the code how it works here. Thank you. Code here as we discuss on whiteboard. So for what I have to do, first we have to check that 3 conditions I said, right? If start should always greater than equal 0, right? Start is the index, and this should also less than the equal of what is the length of array, right? And also this should not visited. How we can check that? If this element is not the negative element, so always should greater than 0, no negative element, right? If this is the condition, then I will check that if this element is 0, so nums, if this is the 0, if this element 0, means we reach our destination, we will return the true. If this is not 0, then you have to mark as a visited, right? So nums start is equal to, make it minus, just for the marking purpose, you can use anything. And then after that we have to again call the same method, right? Return, but this time we have to pass the 2 plus and minus for the index, right? So can reach, pass the same array, and this time start minus nums start, right? or the same thing this time with the plus sign, right? Same thing with the plus sign. If suppose all the visited happen and he didn't get any element, then in this case we will return false. That's it. Let me check this code. Run the code. Method end is not there, so we have to method end. Working fine. Let me submit this code. So it took the 4 milliseconds and performance is good, right? Thank you very much.